So, on page 566, well, we've got this problem. So we're going to go through example 3. So obviously when examples, they take it to a reasonably high level and then we drop back easily for the exercise. So it says up to 10 planes can fly into a particular airport each day. Each US plane can carry 30 tons of supplies and requires 2 crew members. Each British plane can carry 20 tons and requires 1 crew member. There are 14 crew members in total. They can fly on either US or British planes. Find the maximum weight of supplies that can be transported each day. So you can see that's quite a complex paragraph there, lots of information. So you need to develop your strategies going through those and picking out all the information you need. All right. So I know it says in the book, but can you see the variables? What are the variables? The things that we've got. Maya?
X and Y, X being the number of US planes and Y being the number of British planes.
Yeah. So the thing that we don't know at the moment is how many planes are needed, or we have. So you've got your X and your Y variables, and you have to determine from the information what is not known. Can you all see from it where if you didn't have that answer there in front of you, where you would get that from?
Yes.
So what statements in there make you think? Sienna?
Well, it says find the maximum, in order to find the maximum weight, like you need to know how many planes there are, and like it doesn't tell you. So you just know that that's what you have to find.
Okay, Sam, what were you saying?
They can fly on either US or British planes.
Yeah, but how would I know, for instance, is there anything in there, just because at the moment it's easy once you've been given the answer, when you've not got the answer, is there anything in there that will make, oh yeah, those are the 2 variables? Have another go?
Well, as supporting what Sienna's saying, how to find the total weight of supplies that can be transported. So it's like how many tons and how many people are on either US or British plane, kind of like that.
Okay, go on.
You're trying to find the weight, so it says each US plane can carry blank tons, and then each British plane can carry blank tons. That's kind of
Okay, yeah. Yeah.
What if there's up to 10
Yeah, I'd go, there's a clue as well, isn't it? It says up to 10 planes. We know we've got to work out the total weight, so as Maya said, each plane was the weight. You know, you've all said correct things, just that's how you get the information, isn't it? You kind of, what are the variables? What is the unknown? What affects things? And obviously the total weight, find the maximum weight of supplies, where you need to know how many planes you can fly. Okay? All right, so then we've got to, well, what does our list say the next thing is? So we've got identify the variables, identify the constraints. So what are the constraints in that list? Neil?
the number of planes and up to 10.
So we can have up to 10 planes. So how would I write that as an inequality then, Bella?
X plus Y has to be less than or equal to 10.
Yeah. So I've got that first one. Is there any other constraints? Sam?
The amount of crew members.
The amount of crew members. So what would that be then?
There are 14 crew members.
So there are 14 crew members. All right. Do we have to use them all?
No.
No? So, how do we...
You have to.
So there are 14.
So, you see, but you don't have to use them.
But all of them have more than. That's why it says there are.
You could say there are.
Like,
you
there
only
are.
need just a-
It means that you can't use more than 14.
Does it mean we have to use all 14?
No.
No. Well, what are we trying to do in the long run? We're trying to optimise the situation, yeah? So we probably should, unless using all of them reduces the number of planes, for instance, that I can take. Maybe the combination doesn't work in that sense. So we need to be aware of that. All right. So have we got a formula for the number of crew members that will be on? Yeah?
2x plus y
Why?
less than, I don't know.
You don't know, that's the problem. We can read the answers, but why? I've got the same people again. Some people really study it, some people wait for other people to tell me the answers. Oh, read a book, that'd be nice. Yeah, get involved. Bella?
Yeah. Oh. Exactly what Sienna said. 2x plus y.
But why?
Because there's 2 crew members needed per y, per U.S. plane. So that's why it's 2.
2 on
y.
each, yeah,
I
and...
mean 2x. And then y, there's only 1.
Okay, so we've got that piece of information. So 14 crew members, we've got 2 on each US, we've got 1 on each UK. That must be less than or equal to 14. Yeah?
No, I think you need 2 on US and only 1 in British. Don't you need 2 on
It says it in there.
Oh.
That's what I said. Read. You've got to take this info. This is one of those situations where you have to read and reread and read. Because what you do is you take your information from one thing and then go, right, where's the next thing? And you have to go back and read it again. All right? If you don't, all right, you will just get lost. And then you'll put your hand up and go, I don't get it. All right? But you have to read and reread and reread. That's why the answers here are only any good if we know where they're coming from. All right? But looking at the answers, they have a couple of others inequalities. We've only got 2 at the moment. Are there any other constraints? Yeah?
The US plane can carry 30 tons and the British can carry 20.
Okay. So, what can we write? Well, okay. Can we write a thing about the number of planes using that information, or is that something we need at the end?
At the end.
That's the thing at the end. That's going to be our objective function, all right, to work out the weight. So the weight is our objective. But is there any other constraints that we've got to consider? They might seem obvious, but we should write them. Yeah. So to do with the planes, look, we must have x must be greater than 0, less than or equal to 10.
Do you have to use a British
Do we have
plane
to
as
use
well?
a... So we can have none, and we must have the same thing for British planes, yeah? So we've got these 2. So we can't go above 10, we can't go below 0. That's important, isn't it? All right. Now, so we've got our constraints. What about our objective function? So what do I want to maximize or minimize? So I'm trying to work out what is the max what I can carry. So the maximum weight, is it, of supplies? And how would I work out how much weight I'm carrying? Yeah? Okay, so that's the weight. Weight is 30 times a US plane. Every plane has 30 tons. Now, is this an inequality?
No.
No. So that's not a constraint. That's the objective function. That's the thing I want to eventually work out. All right? Now what I need to know is then, well, the weight depends on how many planes I'm allowed to take. Sorry, should be 20, yeah? All right. So what we need to do is figure out what are my feasible options for x and y. So we need to plot these values on a set of axes now. All right. So let's go and do that. Go on then. X plus y equals 10. Bella?
Start at 10.
Yeah.
Go on to 10, and then I would move subtract 1x
Right.
on both sides, and then it would be y equals 10 minus x.
Yeah.
Or negative x plus 10.
Yeah.
And so I'd start at 10, and then I would use the gradient, and then
Yeah.
go down 1 and over 1.
Cross one, down one, cross one, down one. That's one way to do it, and you'd end up there. That's fine if we rearrange it. The other way to think of it is, well, the x and y coordinates need to add up to 10. So it's 0 and 10 and 10 and 0. And then everything in between, 5, 5, 4, 6, 6, 4, so on like that. So these ones are lovely to plot because you just go from the 10 and the 10. That's why I put it, right? What about the 2x plus y equals 14? Again, we could rearrange that to be y equals 14 minus 2x. Or I could do it like, well, if the x coordinate is 0, the y coordinate has to be 14. If the y coordinate is 0, the x coordinate has to be 7. So I'm going to go from 7 up to 14. Okay? That makes sense to people? Then I need my x has to be equal to 10. So I can put in, that's nice. And y 10. So I've got that constraint there. All right. Now I just need to shade in. So what sides of things do I need? Well, x plus y has to actually be less than or equal to 10. This has to be less than or equal to 14. This has to be less than or equal. So they're all solid lines, so that's nice. So I'm going to shade above this one to start with, and I'm going to shade, because I know I can't go past those. Is that all right? So that's dealt with these two. Is everyone happy at why those are what they are? I can't have more than 10 planes, so... All right. What about the x plus y has to be less than 10? Well, that means this line has to be below that. So did these really matter? No, they don't really affect it. And then I've got 2x plus y has to be less than 14, so this line here. So we shade above it because we're only allowed less. So now we've only got this region here. So that's my region. So we've then got to maximize. So the next statement on my list was to do what?
Determine the function to be maximum.
Well, we've got that. We've already gone that one. The next one is to test the coordinates of the vertices. Right? So what we do by then, and I'm going to leave you to get on with this, right? We take the vertices, so this point, this point, this point. Do I want that one? I don't want that one. So why are we testing the vertices? Well, we think that might maximize or minimize. We want to maximize. So we went through it. We'll test these vertices. Now, that gives me a starting point, right? So what are the options at the moment from the vertices? So I've got x and y. So it's either 10 and 0 or 7 and 0, or it's 4 and 6. So 4 and 6. So what am I testing those values in? Well, I've got the weight is, what was it, 30x plus 20y. Okay, so we've got, the first one will be 30 times 0 plus 20 times 10. The second weight will be 30 times 7 and 20 times 0. Then we've got 30 times 4 and 20 times 6. So which one currently gives us the highest?
The last one.
The last one? You can work out those values. Do we think that we maybe could get it even higher? Well, what we can do is that if you think this is the highest, yeah, you've identified one of those vertices, this one. What can we do just to check that that is the maximum? Or we've got other potential values like this value either side of it. Maybe we could check by going one either side and see, does it go up a bit or not? Or is that really the maximum point? I don't want to go anywhere below it that's not on the line, but would it make sense, for instance, to drop 2 UK planes and add 1 US plane?
No.
No, so we can already see without doing the numbers that makes no sense, because we'd lose 2 lots of 20 and only gain 1 lot of 30. What about the other option, which is we lose 1 US plane and only gain 1 British plane? So we lose a 30 and only gain 1 20. So again, so I'm kind of thinking that that will be our optimized point. Right. So that weight, whatever it is, what was it? So 120 plus 120 is 240, what is it, tons, is the maximum weight that I can do. So long process. So for instance, in an exam, this would be like a 12, 13, 14 mark question if you were doing exams like that. So it's, you know, it's not something you be expected to do super quick, but, you know, lots of steps to go through. Right. Any final questions? Fine. Time that perfectly. Any questions? No? So your task is to move on to practice 4 then over the page and carry it on.